Welcome students. In this video we will discuss about the asymptote of any curve. We will try to learn what is the asymptote, how many types of asymptote, and how we can find it with the help of graphical calculator or without calculator also. So first of all, what is the asymptote? So asymptote is a straight line. Asymptote is a straight line along which curve moves parallelly. Curve moves parallelly. This is the fundamental definition. We can define it in another way also, that it is a straight line such that the distance between the distance between the curve distance between the curve and the line, that is my asymptote, tends to 0 tends to 0 as one or both of x or y coordinates approaches to infinity. We will try to understand what is the meaning of second definition and first definition as well. Let's try to understand with the help of an graph. For example, we know the graph of y is equals to e raised to power x. We can plot its graph. So this is e raised to power x, this is y is equals to e raised to power x, and this is my x-axis. So my graph is like this. It passes through 0 comma 1. So if someone asks, is there any asymptote of this curve? So yes, there is a asymptote. As you can see here, what is the meaning of this part? If you try to understand this part, it is saying that if x is minus infinity, if you go towards minus infinity, right, this curve will be approximately going like this. You will feel that it is going parallel to this negative x-axis, or you can say x-axis, like this. There is no drastic change, there is no observable change in the distance or the gap between these two lines, which is shown in red color and yellow color. The red color is your x-axis, the extended part of x-axis, and yellow color is our graph of y is equals to x. So first definition is clear, that it is a straight line along which the curve moves parallelly. So as you can see here, x-axis is that straight line along which my curve is moving parallelly. And according to second definition, it is a straight line such that the distance between the curve and the line, here you can see the distance between curve and the line approaches to 0 or tends to 0. As you can see here, there is no gap, approaching to 0 gap, right? So this, when x or y approaches to infinity, here you can see my x is going to infinity, minus infinity, no problem. So my x is going to towards minus infinity. In this case, as I can see that the gap between this yellow graph, yellow curve, and the red line, that is the x-axis, is tends to 0. So we can say that here x-axis is my asymptote of this curve. Here we can write x-axis is asymptote of this curve. And what's the equation of x-axis? Equation of x-axis is y is equals to 0. So we can say y is equals to 0 is the asymptote, and it's a horizontal line, so we can say it's a horizontal asymptote. Let us go in depth for this discussion. So now we can understand in detail that asymptote can be of three types. One is the horizontal asymptote, one is the horizontal asymptote, second is the vertical asymptote, and third one may be a general, your line will be a general asymptote, a general asymptote, right? What's the equation for a horizontal line? See, a horizontal asymptote will be a straight line, as the definition says it's a straight line. And what's the equation for a horizontal line? It should be y is equals to some constant, right? A vertical asymptote should have equation x is equals to some constant, and a general asymptote you can write y is equals to mx plus b, right? Now I will try to summarize first. Okay, then we will see with some examples, then we will see some questions of previous year examinations or questions. See, so horizontal asymptote. So let's take an example. For example, we have y is equals to x upon, or x square plus 2 upon x minus 2, right, like this. So let us see first vertical asymptote. Vertical asymptote is just like x is equals to infinity, x is equal to constant, right? Your answer should be in form of x is equals to some constant. To find the vertical asymptote is so simple. Without calculator, if you want to find vertical asymptote, it is just like you have to find your domain. What is the meaning of vertical asymptote? See, if you try to understand with this simple coordinate axis diagram, what is the vertical line is. Let us suppose this is a vertical line, x is equals to some x naught. This is the vertical line, x is equals to x naught. What is the meaning of this vertical line? The meaning of this vertical line is, for x is equals to x naught, y can be anything plus minus infinity. For x is equals to x naught, your y can go your plus infinity as well as along the minus infinity as well. It means y is going to be undefined. Y is undefined. If any curve gets infinite value for some value of x, what you will say, this curve gets undefined, because infinity is not defined like this, right? So if you want to find a vertical asymptote, just find its domain, right? The domain, the restricted part of domain is your vertical asymptote. For example, if we try to understand here, it's a rational function, and for the domain you can write x minus 2 should not be equals to 0. Why? If your x minus 2 should be equals to 0, your function will be goes undefined. So here x should not be equals to 2. So this restricted part will be your vertical asymptote. So when we plot this graph, x square upon x square plus 2 upon x minus 2, you will get that x is equals to 2 will be a vertical asymptote. So here, what's the meaning of, what's the conclusion for vertical asymptote? So mathematically we can write, for vertical asymptote we have to find that for what value of x, for what value of x my y goes to plus minus infinity or undefined. This is the condition for to find vertical asymptote. Similarly, if we want to understand for horizontal asymptote, so its meaning is, if we have x tends to plus or minus infinity, if we increase our x to infinity or minus infinity, so what will be the finite value of y, or you can say what's the limiting value of y. So this part will be related to your uh, chapter, that is the limit and continuity in the calculus. So if you know the limit, you can solve it without calculator also. If you know the domain of a function, you can find this without calculator also. And this is a general asymptote question. So we will try to discuss all these, right, with the help of some question. So let us see this first question. This question says we have fx is equals to this. On the diagram, sketch the graph of y is equals to fx, and the value of x should be like between -3 to 5. So let us go to the our graphical display calculator and try to sketch this graph. So okay, so first of all we will go to the function, graphical function, and we have to type this expression. I have already typed this expression. This is 2x minus 1 x minus 1 upon x minus 2. I have to set my view window also. So execute, then view window. Since I have to keep my x between -3 to 5, I have typed here x minimum should be -3, maximum should be 5, scaling is 1, and you can do the execute button. So this is the graph. So first part is completed. Let us see the next part. On the same diagram, draw the sketch of y is equals to 2x plus 1. So we have to draw y is equals to 2x plus 1. So exit. So we have y2 is equals to, what's the graph, 2x plus 1. So we have to type here 2x plus 1. So 2x plus 1, then simply do the execute button, and we have both the graphs on the same line. As you can see here, this red line seems to be a asymptote of this function. As you can see here, this blue part is moving parallelly to this red line here also and above also. Okay, let us see the next part. What it is saying, the write down the equation of asymptote of the function of y is equals to fx. So this is my asymptote. Here my asymptote is y is equals to 2x plus 1 itself. How we can say? We can say because as you can see here, as the curve, okay, for this we can justify it by a trace button, right? If we move along this curve, you can check that it is moving parallelly. See, I am shifting my x towards minus infinity. You can see that both the lines moving parallelly to each other. Similarly, when you shift this cursor to the right hand side, again you will see that this is moving parallelly to the red line. So this red line is itself a asymptote of this function. Solve for fx is equals to 0. That's so simple. What we have to do, simply first of all go to your G solve, so F5, and we have to find its intersection. So intersection, that is the F5 again. So when you will not found, sorry, it's sorry, here it will find the intersection of these two graphs, and it is saying correctly not found because the curve will move parallelly to the red line, it will never intersect it, right? So we have to exit from here. We have to find the roots of fx, that is the y1. So I am deleting my this f2, so y2. So yes, we have deleted this, and now execute. This is the function, and we have to find, we have to solve fx is equals to 0. It means the intersection with x-axis. So we have to find basically x-intercept. So we will go to the G solve and we will find roots directly. So f1. So yes, this is the root for x is equals to 0.5, y is equals to 0, right? So this is the answer. Let us see the next question. Similarly, see the next question. Fx is equals to, we have fx is equals to 3 minus 6 upon x minus 2. On the diagram, a sketch y is equals to fx for x lying between -6 to 6. So similarly, you can draw its graph on the graphical display calculator. Okay, let us go to this, you can directly go to your editing section from F5. So here I want to delete this, so just do F2, delete F1, right? So let us type our expression. So our expression is 3 minus 6 upon 3 minus 6 upon x minus 2. So it's x minus 2, bracket close, simply execute, execute, then go to view window, and we have to keep it between minus 6 to 6. So I will type here from minus 6 execute to 6 execute, and scaling is 1, correct, enter, enter, execute. Okay, so this is the graph of the given function, right? Write down the equation of asymptote for the graph of this. So we have to find its asymptote also. So as you can see, is there any line along which the curve is moving parallelly? So I can see x is equals to 2 line, as you can see here. See, as you can see, this is the x is equals to 2, right? So right, so this line is being parallel to our given curve. As you can see here, it will go like this, it will go like this, right? So the equation of asymptote is x is equals to 2, right? It's a vertical asymptote. We can find it directly also. How? Let's see. Without calculator you can also find this. See, we have to find its asymptote. So this function will have the denominator as x minus 2, and in numerator you will have 3x minus 2 minus 6, like this. So for fx to be defined, denominator should never be 0. So you can think like this also, x minus 2 should never be 0. So x should not be equals to 2, right? So in the next part we have to solve for fx is equals to minus of x. So first we will draw the graph of this, second we will draw the graph of y is equals to minus x, then we will see the intersection point y is equals to minus x. You can go directly to your editing section by this F6 button. So I am writing this y is equals to negative of x, so it's negative of x. Simply execute this. Yes, so now we have to find its intersection point. So go to gsolve, that is the F5, and find its intersection, that is the again F5. So this is this, for x is equals to minus 4, y is equals to 4. This is the first intersection point, and the next intersection point will be here, for x is equals to 3, y is equals to minus 3. So we have completed this question. Let us see the next question, that is a very important, and I think this will be our last question for this discussion. So here it is saying fx is equals to this. On the diagram, sketch the graph of y is equals to fx lying between minus 4 to 4. So what we have to do, we have to use our graphical display calculator to sketch this function, right? So let us go to the graphical display calculator, go to your editing section directly from here. I am deleting my all these expressions, so delete F1, this, delete, yes. So now I am typing my expression as x plus, so write x plus 1 over x, this, plus 3, so it's plus 3, and then execute, execute. Then I have to adjust its view window, so my view window should be between minus 4 to 4. So I'm writing here minus 4, execute, to 4, execute, x scaling should be 1, execute this is my graph, right? This is the first part. Let us see the next part. Find the zeros of fx. What's the meaning of zeros of fx? Zeros of fx means you have to find its x-intercept. So we have to go to your gsolve, then x-intercept means roots. So just click its root, that is the f1. So it is giving roots minus 2.618, and the next root will be Here x is equals to minus 0.381. So these two are the roots of the equation. Let us see the next part. Solve the inequality fx less than equals to 0. We have to find fx less than equals to 0. What is the meaning of fx less than equals to 0? Right? Fx less than equals to 0 means fx less than equals to 0 means fx should be negative. So see, for this type of question I will suggest that if you want to understand and if you want to answer it correctly, see, first of all, how many is the root? See, you want to find fx less than 0. First find where it will be equals to 0, right? So it will be equals to 0 at 2 points. One is 0 point minus 0.381 and the other point was minus 2.61, right? So when you mark these two roots on a number line, our number line gets divided into three parts. This is the first part, this is the second part, and this is going to be third part. Let us see. In the first part, that is before this solution point, as you can see, it's going below the x-axis. Here it is equals to 0. At this point it is equals to 0. Left of this it is going downward. So this is our answer. It means x should be less than minus 2.61. From minus 2.61 to this point, it is above the x-axis. It means it's positive. After this it's going to be negative again, but before 0, after 0 it is going to be positive. See here, after 0 it's going to go. So my answer will be x should be greater than minus 0.381 but less than 0. Why? Because after x is equals to 0 it's going to be plus infinity. So this is the answer. I hope you have understood this. Let us see the next part. It is saying the asymptote of the curve is, its asymptotes are, see, its asymptote are x is equals to a and y is equals to x plus b, where a and b are integers. Find the value of a and b. So you can see here, this x is equals to a line will be your vertical asymptote, and this is a general asymptote. It is neither vertical nor horizontal. So it's, as you can see here, its slope is 1. Y is equals to mx plus b, so it is y is equals to x plus b. So we have to find the value of a and b. That's a very good question. So to find the vertical asymptote, you can simply go to your calculator. So vertical asymptote, it's clear from the diagram that its vertical asymptote is this y-axis. As you can see here, it's y-axis. So vertical asymptote is x is equals to 0. According to question, it was x is equals to a, so a is equals to 0. What's the other asymptote? The other asymptote has equation y is equals to x plus b. It's not exactly the horizontal asymptote, it's a general asymptote. So how we can find b? That's the important question here. So for this I have a trick. See, I have a general asymptote, and we have some information about this general asymptote, this general line which is going to be asymptote, that its slope is 1, just we don't know its y-intercept. So what I will do, and I have other information that b is a integer. B is my integer, it's not any fractional value. So what I will do, I am planning that go to your editing section, and I will try to sketch a straight line whose slope is 1 and its y-intercept I will use my hit and trial method, right? So I'm going to write here y is equals to x plus 1, sorry, x plus 1. So why I have put it here y is equal to x plus 1? Because question is saying its format is y is equals to x plus b, right? So I have put it here b is equals to 1. 0 should not be my asymptote. Why? Because it will become a y is equals to x, a simple passing through origin line, and this is not going to be asymptote. See, if okay, so as you can see here, y is equals to x plus 1 is not a asymptote, not a suitable asymptote, because it's cutting the curve here, as you can see. So again, I will go to editing section and just I will change its y-intercept. I have put it here 2 and do the execute button, sketch. Still this is intersecting the curve, so this is not going to be a asymptote. So I will go to the editing section and I will try it for 3, execute. Yes, as you can see here, when you will see this, it seems that it is intersecting, but if you have doubt, then what we can do, we can find its intersection point. Is there any intersection point? So we will go to gsolve and we will find its intersection. So let me find. So yes, not found. So there is no any intersection between this line and this curve. So our assumption is correct that this line is going to be our asymptote. So it is y is equals to x plus 3. So my b is 3. So we get the value of a, we get the value of b, right? Let us see the next part. It is saying that we have gx is equals to, we have gx is equals to x plus 1 by x. Describe fully the single transformation that maps the graph of y is equals to fx to y is equals to this. So simply what we have to do, we have to see fx, we have to make fx to gx. Here fx you have plus 3, you want here minus 3. So we have to simply translate the graph with 0 and minus 3. We have to reduce, we have to subtract 3 from its y value everywhere. So we will transform it by 0 and minus 3. This is my transform, this is my translation, right? So this is the single transformation that will give me gx from fx. So students, I hope you have understood this discussion. If you have understood something and if you like this discussion, please like this video. Thank you. Thanks for watching.